All right, I'm going to talk through a bit of this assignment. It's 10.9 EP2, and it's all about logarithms. Remember that logarithms are the inverse of exponentiation. Exponential functions are, of course, inverses with logarithmic functions. That's how logarithmic functions are defined. But what we want to talk about now is the product, quotient, and power properties of logarithms. And so the product property, of course, says if you have two logarithms and you add them, you can combine them into a single logarithm by multiplying the stuff inside. And the reverse is also true, which is what we're going to use down here. If you have a logarithm of two things that are multiplied, you can write it as the sum of two logarithms. Quotient property says if you subtract two logarithms, you can divide the stuff inside. And if you have stuff that's divided, you could also write it as the difference of two logarithms. And the power property says if you have a logarithm of something raised to a power, a to the p, that is the same as multiplying by that power out front. So I'm not going to do all of these, but let's take a look at number 1. So what I'm noticing here is I have 10 times x. That is, by the way, what does it say? Use properties of logarithms to rewrite each expression in lowest terms, which basically means expand the logarithms to a sum or difference or pull out a power. So if I have a product, I know that I can make that into a sum of logarithms. So this is going to be log of 10 plus log of x, because if I have a sum of two logs, I would multiply the stuff inside, and that would end up being log of 10x. Now, log of 10 is asking me 10 to which power is 10, or which power of 10 is 10, and that's 1, so I could just write this as 1 plus log x as well. All right, let's skip over number 2 and look at number 3. Now what I'm seeing here is a quotient. I have square root 3x divided by 7. And when I have a quotient, I know that I should be able to make that into two logarithms that are being subtracted from one another. So this could be written as ln of square root 3x minus ln of 7. Remember, ln is log base e, but we write it as ln, the natural log. Now I can keep going because square root is a power. That's ln of 3x all to the, I'll let you think about that. What power is the square root? Well, square root is the 1/2 power. So now what I have is I have a logarithm with something raised to a power, something raised to a power, something raised to a power. And if I have something raised to a power in my logarithm, I can make that multiplication out front. So that should now be 1/2 times ln of 3x minus ln of 7. Right? The power becomes multiplication out front. And finally, this is a product. And I know that if I have a product inside my logarithm, I should be able to make that the sum of two logarithms. So this will finally be 1/2 times ln of 3 plus ln of x minus ln of 7, or I could write it as 1/2 ln 3 plus 1/2 ln x minus ln 7. Okay, so there's a couple examples of how you might approach these problems, and I'll let you think about 2, 4, 5, and 6. Okay, let's turn the page. So now what we're trying to do is the reverse. We're trying to combine these into a logarithmic quantity. So what I'm going to look for is a difference of logs, which could be made into a quotient, a sum of logs, which could be made into a product, maybe multiplication out front that could be made into a power. Okay. Generally, if you have any multiplication out front, you want to make those powers first and then combine the logs in other ways. Let's take a look at number 8. Here's addition, so I know if I'm adding two logs with the same base, I can multiply the stuff inside. And then I'm subtracting log base 2 of 3. So I combine these two by multiplying the 5 and the x. I know if you add two logarithms with the same base, it combines to one logarithm, multiply the stuff inside. However, if I subtract two logarithms with the same base, I should divide 5x by 3 to get log base 2 of 5x over 3. Now I've combined it into a single logarithmic quantity. Let's take a look at number 10. When you multiply a logarithm by a number, it can become a power inside. So the first thing I'm going to do is make this ln of x cubed plus ln of y squared minus ln of z to the 4th power. So I'm basically making these multiplications out front exponents. Now I have addition. So addition of two logs with the same base. Of course, these are base e. Right? This is asking me e to what power is x cubed. Well, I don't know what that is because it's a variable, but that's really what this is asking. So this can become ln of x cubed y squared minus ln of z to the 4th. And now if I have basically subtraction, that is going to become division. So that would be ln of x cubed y squared over z to the 4th, or of course I could write it as ln of x cubed y squared z to the, if I want to move the z to the 4th up, it would become z to the, hopefully you remember, negative 4, right? Because a negative exponent means divide. And interestingly enough, if instead of doing z to the 4th here, if I had kept the negative, I would have had plus ln z to the negative 4. And then I would have ended up with this. So either way you can do that. Okay, so I'll let you think about 7, 9, and 11. Now let's move on to 12, 13, 14, 15. It says, using properties of logarithms, find the following values of the expressions written in numbers 12 to 15 if log base b of 3 equals this, log base b of 2 equals this, and log base b of 7 equals this. So what we're given is we don't know what the base is. We can't just find it on our calculator. But we do know that log base b of 3 is this, log base b of 2 is this, log base b of 7 is this. So if we can rewrite these in terms of 3, 2, and 7 using properties, we can figure these out. So I'm going to look at 18 and try and think about how 18 relates to 3, 2, and 7. Well, 18 is 3 times 3 times 2, right? And that, the reason I want to write it as 3 times 3 times 2 is it's because it's using these numbers right here. So I'm going to write this as log base b of 3 times 3 times 2, because 3 times 3 times 2 is the same as 18. And now what I know is if I have a product inside my logarithm, I can make it a sum of logs. So that's going to be log base b of 3 plus log base b of 3 plus log base b of 2. And that goes with the product property. Adding logs with the same base, multiply the stuff inside. But now I know what log base b of 3 is. I know what log base b of 2 is, so I should be able to then just say this is going to be equal to 0.477 plus 0.477 plus 0.301, which is going to equal some number. I don't have my calculator on me right now. Can you believe it? But, well, actually I do, but it's right up here. It's the phone that's taking this video. So you can find this on your calculator. Okay, fine. I could do it. I could do it in my head, couldn't I? Seems maybe not in my head. Let's see. 0.47. Oh my goodness. Okay. 0.477, 0.477, 0.301. Let's add it. 7, 8, and 7 makes 15. 7, 14, 15 again. 3, 7, 8, and 4 makes 12. So maybe 1.255. Might be worth double checking that, but Hopefully that's right. Let's look at one other example here, log base b of 3b squared. Well, what I'm noticing is that I've got a product here of 3 times b squared. Remember that 3b squared is not the same as 3b squared. So I can't use the power property because I'm not squaring this entire thing, just the b. But I can write this as log base b of 3 plus log base b of b squared because that's a product inside there, so I can make it a sum of the two logs. Well, I know what log base b of 3 is. It's 0.477. And this is just asking me b to which power is b squared? B to what is b squared? 2. So this is 2, and I end up with 2.477. Okay, so I'll let you think about 13 and 14. Now finally, okay, on the back, we've got a few equations. Solve the following logarithmic equations. Some strategies that may be helpful: use properties to combine 2 or more logarithms. Okay. Convert a logarithmic equation into exponential form. Okay. Or exponentiate both sides of the equation. Okay. These last two are kind of the same thing-ish. The same, but slightly different. Let's take a look at A. We've got just one logarithm equals 4. I think this would be, we can't really use properties to combine 2 or more logarithms because this is just one logarithm. And so maybe converting this logarithmic equation into exponential form would be a good idea. So this has a little base of e, and I can use my little circle here. E to the 4th is the stuff inside. Remember, the log is always equal to the exponent. The base has to be the same, and it's going to equal 5x minus 2. Well, now that you have e to the 4th equals 5x minus 2, you can just see what's been done to x. So I multiplied by 5, subtracted 2. So I can add 2. Now I have e to the 4th plus 2 equals 5x, and then I can divide everything by 5 and get x equals e to the 4th plus 2 divided by 5. Okay, again, if I look at x here, what's been done to it is I multiplied it by 5, subtracted 2, and took the natural log. So to undo that, I need to raise e to it. That's the inverse of the natural log. Then I need to add 2 and divide by 5. Let's take a look at D, and then I'll let you think about the other one. So log base 2 of x plus 4 minus log base 2 of x minus 4. I see the difference of two logarithms. I can combine that into one log. Log base 2 of x plus 4 divided by x minus 4, right? If you have two logs subtracted, you can divide this by this, and that's going to give me 3. So I combine my two logs that are subtracted into a single log by dividing the stuff inside. Now I can convert it to exponential form and get 2 cubed equals x plus 4 over x minus 4. So 8 equals x plus 4 over x minus 4. Now this is 8 over 1 equals that. So one thing I could do is use a cross products property and say this times this equals this times this. So then 8 times x minus 4 is equal to x plus 4 times 1. Now I can get 8x minus 32 equals x plus 4. Add 32, subtract x. Now I have 7x equals 32 plus 4, which is 36. So x should be 36/7. Okay. Hopefully there's nothing on the back page, thank goodness. And then there's some true or false here that are kind of interesting, and I think you'll be able to figure these out. One of them I think is true, and the other ones are definitely false, but they're common mistakes. Okay, so that's about a 15-minute video there. Hopefully with an additional, I would hope with an additional 25 minutes, maybe you could do a couple of these, a couple of these, and a couple of these. Maybe not finish completely, but get pretty close and maybe have some questions. All right, see you on Monday.